To get someone who's a pretty dynamic, fun presenter. So, do as I say, not as I do. And then find somebody who's a expert in the technologies your team use. There are a lot of people who are pretty well-rounded security experts, but they use a lot of JavaScript and they don't know anything about JavaScript vulnerabilities, or you're using struts and they don't know anything about struts, or it's just make sure the training is tailored to the tools your team are using. And make sure that you're actually measuring your success and the retention of the knowledge that gets imparted. So to make presentations more interesting, books that I did, first, if you're really just trying to hit developers, say, here's the minimum you need to know, here's actionable guidance. We tried doing that with the 19 Deadly Sins of Software Security. That's a book that you can give to a developer with the expectation that they should never be a security expert. They just need to be minimally security aware. When they need to think about security, they do the least amount of work possible, open up the book, go down the checklist, and see if they did the right things or not. Right? That's the kind of thing you should be looking for the average developer. And for making your presentations interesting, books that I did not crack open whatsoever during the making of my part of this presentation, Tufte's Beautiful Evidence is a wonderful book that will teach you how to do a good job of presenting stuff without using PowerPoint whatsoever. PowerPoint is actually a horrible communication mechanism, which is why I use it. I really don't want you guys to learn anything today. I really don't. So then Tom Peters' Reimagine also people apparently find very helpful for putting together a presentation, but I wouldn't actually know. So the next best practice area is doing assessments and audits. A lot of people do this. You hear a few very popular things: threat modeling, which some people call architectural analysis, web penetration testing. So using tools like those that come from Watchfire, Spy Dynamics, and so on, and doing code security inspections, actually looking at the code to see if there are security problems. So let's look at these really briefly. Threat modeling, basically, usually what happens is you throw a bunch of people in a room and ask them to come up with good ideas on how they could break software. You basically say, hey, brainstorm. Most people do this without any process, no repeatability, and the results are about as good as the people who are in the room, which in most companies is not that great, but it's, okay. It's as good as the training you gave the developers, and once you take out everything they've forgotten about. So threat models are actually fairly expensive to build, but nowhere near as expensive as doing a full code review on something, because doing an architectural analysis is usually the first step of doing a code review anyway. So, but this stuff is a waste of time if you're not actually going to act on this stuff. And a lot of people come up with things that are only theoretical. They never follow through to see whether it could happen or not. They're just going to say, we assume that it doesn't. They just enjoy playing what-if games. And then another point here is that people will come up with a good threat model and then never track it as the software changes. But guess what? Software does change, and you can introduce new problems, and it happens all the time. So if you care about threat modeling, you better update it when you update your software. So these we would say are moderately effective. They work pretty well most of the time. They don't catch everything, certainly. There are a lot of things that you really can only catch in implementation, and usually people just aren't going to do it. You really that's very rare. So the cost effectiveness tends to be okay. If you go externally, it tends to be pretty expensive. If you can get it done internally, you can often find people who are really passionate about security. They want to do a good job, and they will help you do a threat model and still get their work done that you were expecting them to get done that week. You just don't put a time box around it. You don't put it in the schedule. You just give them a month or two, and something will come up that you can discuss. So it's actually not too hard to get people to do this job, and not really have to spend a dime to do it. And you just got to look for the champions. They're out there. You just got to cultivate them. So let's move on to analysis tools. Here's a blog entry from a year or a year and a half ago about somebody who took the Clockwork analysis tool and ran it against the Mozilla code base. And here's a response from the Mozilla developer. I'll summarize this discussion for you. Basically, there were 611 defects found in Mozilla, and 71 of them were determined to be vulnerabilities. Out of all of those, though, the Mozilla developers found that only 3 were bugs. So the question is, was that analysis tool then almost 100% useless? Certainly, it's going to take us a lot of time and energy to review about 700 results to try to figure out, what's real and what's not. Is that cost effective? Probably not. But web penetration testing tools, this is the most popular type of tool out there right now. Basically, if you've got an application that has a web component to it, it's a black box testing tool that will bang against it and try inputs that are meant to kind of elicit evidence of SQL injection, cross-site scripting, so on and so forth. These things don't really give the greatest results in general. I mean, they typically have large false positive rates, and they often miss a whole lot of real problems. There's just a lot that they can't test for, and that's another talk in and of itself. But you can expect that everybody is going to run this tool against your site, this kind of tool against your site. So this is actually, even though there's a huge hidden cost here, there's a lot to do with the results, because you're going to get spammed, but you have to do a lot of work because with those results, because you got to ask which ones are the problems, and then what do I do about those problems. So now you got to say, answer these questions. Where in the code does you said there's a problem when I put in this input. Where in the code does that problem manifest itself? What is the problem, and how do I fix it? And that's pretty challenging. There's a lot of cost associated with that the average that you got to count. All right, what about static analysis tools? Static analysis tools are definitely useful for finding security problems. They are capable of having very low false negative rates and very low false positive rates for most types of security problems. But in reality, they're very difficult to use. They really don't work for most environments, and it just requires experts to run them and use them effectively. All of the tools that are on the market today, I would rate to be pretty poor in terms of being cost effective for an organization. So that doesn't mean that you shouldn't use them. It just means that it tends not to be the most cost-effective thing to do. If you are doing audits anyway, if somebody says audit this product, then this actually does start becoming a very cost-effective way to reduce the amount of time it takes your developers to do the audit, if you can find something like a real static analysis tool that doesn't give you too many bogus results. If you use tools like the first couple of tools that the industry wrote, they're just grepping for problems, and you're going to get spammed again, right? I mean, you're going to see the big the spam machine. So what do we recommend so far as audits go? Well, I think that it really certainly is going to depend on your environment. We typically do threat modeling on a team-by-team basis at McAfee. It's not a requirement that we push down. Teams don't have to do threat modeling, and we don't like it to have a impact on the schedule. If they're going to do it, they want to do it, that's great, but we don't like to see it take up too much of the schedule. Then we'll have David's team review what the development team does, and they'll usually do their own threat model, but we don't go through the Microsoft process for threat modeling. Microsoft spends billions of dollars, and nobody wants to do that, right? So the average threat model coming out of Microsoft is dozens and dozens of pages, and that's just way too much work just to produce all the reams of dead trees. And so be smart about it. We think that the most appropriate thing for you to be doing for static analysis, we definitely like static analysis, but not in the way you would think. Like I said, we do use it for our own product security reviews, but it's really a minor part of our program. We only tend to use it on our highest priced jewels on any regular basis whatsoever. But what we do is we actually use those grep tools that I was deriding a couple of minutes ago, and we use that to enforce coding guidelines. We give our developers coding guidelines, and when they check code in, if it doesn't meet those coding guidelines, they'll get a nasty gram saying, here are the basically you shouldn't have used a stir copy, you should have used this instead. And then it doesn't really matter if it was a problem or not. They just fix it, and those common things that everybody complains about and are easy to find tend to go away. Now, there's no way you're going to do that on a legacy code base of millions of lines of code. It just does not work at all. So we only do this kind of thing for new code that you check in. All right. So. Final thing I'm going to talk about in this best practice, and then I'm going to turn it over to David to go through the rest of the best practices, is when you do a code audit, when you decide because somebody told you to, or because you're trying to get ahead of the curve and see if you can get the ones that, because nobody ever cared about security on that product. It's something you acquired and you want to see how good it is or it isn't. There are a lot of reasons to do a code review, but you're never going to want to fix all the problems a code review that you find in a code review. So the obvious answer here is, you got to prioritize and only fix what makes sense to fix. Now, that to me means the stuff that's cost effective to fix, and often that's quite a few things if they're really easy fixes, but sometimes the fix is really challenging, or if you have so many fixes, the little things add up. And so for some companies it means only the stuff that the bad guys would have found through black box testing, or through black box testing. Yeah. So here are some of the questions that we tend to ask, and we probably fix more stuff than the average company because we care a lot about the problem, being a security company ourselves with a big brand. But a lot of people ask these questions and come back and say, we don't want to fix any of these problems, and then the typical app security company will go off in a huff and not understand. Anyway.
UA. This is another best practice area where clearly communicating the coding guidelines, the secure coding guidelines, is one of the best things to do. You tell the developers exactly what you'll be looking for. You're empowering the developers to educate them as to what they're looking for in their code when they're doing their own code reviews within their teams. We provide a worksheet at the end of our coding standards to allow them a checklist to go through and examine what areas they